Hello. So today we will be solving this problem, longest increasing path in a matrix. We were solving 2D dynamic problems from this sheet, neetcode.io. So we have solved these six problems successfully, and now we are moving to this particular problem, longest increasing path in a matrix. Okay. So let's read out the problem. So the problem says given an m into n integers matrix, return the length of the longest path in the matrix. From each cell you can either move into four directions: left, right, up, down. You may not move diagonally or move outside the boundary. Okay, we are given an m into n matrix. We have to return the length of the longest increasing path. Okay, means here the length is 4, meaning this path is longest increasing path, means this is increasing path 1 to 2, 2 to 6, 6 to 9. Okay, I think the path should be strictly increasing, because if the paths are not strictly increasing, then length was supposed to be 5, because this will then also be considered as a increasing path. Okay, so here the answer is 4, because we have these four numbers in the increasing order. Okay, means we can start from any cell in the matrix and count the increasing subsequence from there. Okay, and for this particular example, we are starting from 3 and answer is 4. Okay, and here answer is 1. Okay, okay, this means we can start from any cell. Okay, so we can try from every cell, starting from every cell, and we'll move in four directions, and we'll only go to the cells which have the current value greater than the current cell. Okay, and for a particular cell we can store that the longest increasing subsequence starting from that particular cell. Okay, so in that way we can convert it into dp. Okay, so let's first define the indexes of our matrix, dimensions of our matrix. Okay, so we need to start from every cell, let's say. Okay, means in worst case, if means our answer will be at least 1, because a single number will form a subsequence of length 1 in itself. So suppose we start from, we call a function Find longest increasing path. Initially we are at ith and jth cell. And this is our matrix. Okay, and this function will return us some value, means value of the increasing subsequence starting from this particular cell. Let's say initially our answer will be uh, 0, then our answer should be maximum of the answer and 1 plus this value, because we are considering 1 because we are starting from the uh, a given cell, means we are, that's why adding 1 to it, and at the end we need to return this answer. Okay, so let's implement this function. So initially we are at this position in cell. Okay, we can also pass n and m also. Int n, int m. Okay, so now we are at this particular cell. So from this particular cell we can move into 4 directions. So let's initialize a direction vector which will help us to move into all the 4 directions. I have used this particular direction vector in graph problems. Okay, so this is our direction vector. So we need to move in these 4 directions. So this basically represents the all the 4 directions, means we will be adding this value to ith and ith cell, ith row, means, and this value to the jth column, and we, that's how we will be getting the all the 4 directions. So we, our current direction in directions, so x will be our adjacent column, adjacent row, and y will be adjacent column, j plus dir of 1. Okay, so we have found a adjacent cell. So in iterating directions vector into all 4 directions, we will find all the 4 adjacent cells. Okay, now we need to move into these adjacent cells. So basically we have a condition that uh, first these cell indices need to be valid, and also the value present at this particular let's say this particular cell should be greater than the current value. So if x is greater than 0 and y is greater than 0 and my x smaller than n and y smaller than m, and one more condition, if all these conditions satisfy, that means my x and y are valid, I will check if matrix of xy, if it's greater than matrix of ij, then only I can move to that particular cell. Let's define length as 0 initially. So what we will do, we will take length as the maximum of current length and 1 plus find longest increasing path function, and we will pass the new cell, the adjacent cell x and y, and the matrix and the parameters n and m. And at the end we can return our length. Okay, so we don't need, I think, a visited vector, because we will be only moving to the cells which are greater in value. We will not reiterate a cell again in the path, because that cell will be having the smaller value as compared to the current cell in which we are standing. So we can't retrace any cell, so that's why we don't need a visited array. Okay, let's run this, see if this brute force approach works. Okay, we are having some issue. mm, okay, so our function is void type, we need to make it int type. Okay, we are having another issue. Okay, the spelling mistake. Matrix. Okay, here also. Let's run this. Okay, we are getting correct length, but this will be let's say we are starting from every cell, and for every cell we are visiting every possible path. Okay, so what will be the time complexity? Means this is n square, means n into m, and into that mm, we are calling this particular function. Okay, then what should be its time complexity? N into m into we are iterating every cell, so I think its time complexity should be n into m into n plus m, or it will be greater. mm, we are means this is a DFS function, so let's ask ChatGPT what is the time complexity of this particular solution. ChatGPT. Okay, so the Number of recursive calls for each cell in matrix. Okay, so it's exponential time complexity. Okay, we have four calls and 4 n into m into 4 raised to power n into m. Okay, because I think we are having a four calls, and for that four calls we are calling our uh, this function. So that's why this is 4 raised to the power n into m. Okay, so we can memorize it, means we can, for this particular cell, we can store that uh, the longest sequence which starts from this particular cell. So we can use dp. Let's to store the states at the particular cell. So we can initialize our dp as with -1, and we can pass our dp in this function call also. Okay, and we can check here that if we have already solved the sub problem for this particular cell, means if it's not -1, then we can return the answer that for this particular cell the maximum sequence is this. Otherwise we will calculate for this cell, and at the end we can store it in the dp. And we also need to pass dp here also. Let's run this. Okay, what issue we are having, we need to pass dp here also. Okay, let's submit this. Okay, so this was the solution for it. So I think it it is more of a medium problem than of a hard problem. So we have just used the dfs and just memorize it. So that's the only thing we have done here. So let's see my previous submissions. I think that would be same. So it was in 22. Okay, it's exactly same. So I think it's the good approach to use it like this. Okay, so this was the problem, longest increasing path in a matrix. Okay, I think that is it. Thank you.